This is Mr. Krenz, and in this video I'm going to teach you how to factor polynomials with polynomial long division. Now, if you're not quite sure what polynomial long division is, I'd urge you to go back and watch that video and do some practice there. If you do know what it is, factoring with long division is pretty easy. Alright, so the key with it is you have to know a factor already. In this case, I've just been telling you what a factor is. When we get into solving or graphing, we're going to have a theorem called the rational roots theorem, which can give you some clues of what one of the factors might be. Okay. But in this case, I'm given a cubic, x cubed minus 19x minus 30, and I'm being told that x plus 30 is one of the factors. Now, if x plus 3 is a factor, that must mean that I can divide this cubic by x plus 3, and it comes out evenly. Just like if I have the number 36, and I tell you that 9 is a factor, or if 9 is a factor, that must tell me that when I divide these things, they come out nice and even with no remainder. So what I'm going to do here then is I am going to divide this polynomial by the factor. So I set it up, polynomial long division. I have x cubed minus 19x minus 30. That's being divided by x plus 3. Now, the thing you have to be careful with here with the polynomial long division is that it jumps from x cubed just to x. And there, I may need an x squared term, so I'm actually going to erase this part of it and add in a 0x squared. And again, the reason for that is just because this term does not have an x squared does not mean if I divide this polynomial by the factor that I won't have an x squared term. So polynomial long division, I look at the x, I look at the x squared, and I decide I need an x, I look at x and x cubed, and I know that I need x squared. So I compare these guys, and let's see, x squared times x is x cubed. X squared times 3 is 3x squared. Remember, subtract here. X cubed minus x cubed is 0. 0x squared minus 3x squared gives me a minus 3x squared. Drop down negative 19x. Compare x and negative 3x squared. Determine that I need a minus 3x. Minus 3x times x gives me minus 3x squared. And negative 3x times 3 gives me minus 9x. Subtract here. Negative 3x squared minus a negative 3x squared will give me a 0. Negative 19x minus a negative 9x is the same thing as negative 19x plus 9x, which gives me a negative 10x. Drop down the negative 30. Compare negative 10x and x. So we need minus 10. Multiply it by both. And minus 10x minus 30. And since those are the same, they all subtract to give us 0. Okay? So that's polynomial long division. The 0 tells us that it divides evenly. But now we can look at it and say, okay, well, that must mean then that this polynomial, x cubed minus 19x minus 30, is equal to this factor times what's left of it. Okay. Reason why that's true, besides just thinking about what factors mean in general, and we know like if 36 is equal to 9 times 4, that means that 9 is a factor of 36, also means that 4 is a factor of 36. We're writing it this way. We have the general thing, and then here are its two factors. Another way of seeing this is what we basically have done. If I erase this guy, we divided this by x plus 3. So it tells me if I take this polynomial and divide it by x plus 3, I get this remaining. And if this is true, I can multiply both sides by x plus 3. x plus 3 divided by x plus 3, those guys would cancel out. And I would get that statement. Again, just to focus on really what we're doing here, is I took the polynomial, I divided it by the factor, and I simplified it into two factors. Now at this point, you take a look. I cannot factor x plus 3 any further, so that part's done. X squared minus 3x minus 10, it's a quadratic that does look like I can factor. So for here, I could do it in my head. I could use product sum. So here I need product sum numbers. See, 1 times negative 10 is negative 10. I need negative 3. So factors of negative 10 that add up to negative 3. I come up with negative 5 and 2. So this isn't a factor, that's x plus 3 times x minus 5 times x plus 2. So if I'm given a root, a very straightforward way of finding other factors is to divide that one factor out and then be able to factor the rest of it. Right. I do have one second example, and give me a second while I get that out there. Example 2, we have x cubed plus 4x squared plus x minus 6, and x minus 1 is a factor. If x minus 1 is a factor, that must mean that I can divide it out of this polynomial nicely. So I will set up polynomial long division. And now let's divide. For x and x cubed, I need an x squared. Multiply that by both these terms. Subtract. X cubed minus x cubed is 0. 4x squared minus a negative x squared gives me a 5x squared. Drop down the x. Compare x and 5x squared. I need 5x there. Multiply 5x by both of these terms. 5x squared minus 5x. Subtract. 5x squared minus 5x squared is 0. X minus a negative 5x is going to give me a positive 6x. Drop down the negative 6. Compare 6x and x. I need a plus 6. Multiply 6 by both terms. Give me 6x minus 6. Subtract the same thing to get 0. Tells me is that x minus 1 is indeed a factor, which I already knew, but this also confirms that I probably did things right. Now what does this mean? It means that this polynomial, x cubed plus 4x squared plus x minus 6, is equal to this factor, the one we knew, minus the one we didn't know, x squared plus 5x plus 6. So here's our first factorization, but not our complete factorization. To be complete, we have to make sure that we can, if there are any terms we can factor, we factor them. This is a quadratic. Looks like I could do a product sum. I need a product of 1 times 6, which is 6. A sum of 5. Factors of 6, I could try 1 and 6, but they sum to 7. 2 times 3 is 6, and 2 and 3 add to 5, so it must be 2 and 3. So that'll factor then as x minus 1 times x plus 2 and x plus 3. So to sum up polynomial long division, if we're given a factor of a polynomial, we can divide that factor out and know that it should come out evenly, and that will reduce the polynomial. We'll have the factor, then we'll have whatever will be left after divided. This is always going to be a smaller degree than the original, so when I take the cubic and I divide out one factor, I'm left with a quadratic. And the quadratic from there, we have lots of different ways of factoring those. Factor that down, so I get x minus 1 times x plus 2 times x plus 3.